This is Art 157, Class 1, Introduction to Using Unreal Development Kit. First thing you want to do is to go online and download Unreal, which is free. So you go to www.udk.com. UDK stands for Unreal Development Kit. And you'll see there's some different options. And what we want to do is we are interested in actually following the UDK link. So we'll click that, and we'll go down and we'll look, and you'll see right there it says downloads. Click the download link, and you come, and there'll be different ones. So you just want to hit the latest released, select it, save it to your desktop, and run. And if you're curious, here are the specs for it, and just be aware it's only available for PC. We're going to be using the recommended content for development. We're not going to be doing any DirectX 11. That's for basically next generation video game consoles, which will be coming out in the next couple of years. So we'll leave that alone for the time being. Okay, you get that downloaded, get it installed, and then you want to go to All Programs. Go down to Unreal Development Kit, and there's different versions every month. They usually come out with a new version, so it's by the date. So you can see 2012-07. So that's the version that I'm currently using, and in this demo. And then you'll see there's a UDK editor and UDK game. The game basically launches, enables you to play by default first-person shooters, capture the flag, and a couple other game types. The UDK editor is actually what we'll be using this semester, and that's the thing you use to actually make games. So you can click this, but I usually find it's easier to just right-click, copy this, and then paste it onto the desktop, and now I have a link that goes to UDK editor. Now if you have multiple versions, you might want to change the name, but if you just have one version installed, it's not a problem. Okay, so you want to double click UDK editor, pull it up. And you always have to be patient. Unreal is pretty processor intensive, so you want to make sure that there's no other programs open while you're doing this, especially something like 3D Max. Unless your computer can handle it, it's really gonna the two programs are gonna fight over your graphics card, Photoshop as well. So you just need to be a little patient and just be aware of how much RAM you have and how quick your graphics card is. So, and there we go. Okay. So here we go. So there's a screen. The video tutorials, I have links in the assignment sheet, but if you want, there are video tutorials which can be helpful. I usually don't show the startup screen, so I'll just disable that and hit close. And now I'm in the Unreal, the basic setup. Now this window, which is called the content browser, we're not going to be using this for this assignment, so you can close that out. And what you're going to end up with is an environment that you start with. Now we want to create a world from scratch. You can see this one already has clouds and fog and a cube and lighting and everything. We want to learn how to do all this from scratch. So we're going to do File, New Level, and at the prompt we're going to choose Blank Map, or Blank Map. And now you can see here's our map, here's our ground plane, and here's this thing called a brush, what we'll talk about, and then there's your axis. Now in the upper left hand corner you'll see it says P. That's your viewport type. In the upper right hand corner there's a restore viewport option, and when you do that you get 3 2D views, which are also called orthographic, and then you get 1 perspective view as well. So this is the format that I recommend working in, as opposed to another type of format. And just to kind of get familiar with these, if you hold down the left mouse button in the perspective viewport, it moves in and out. Let me actually maximize this so you can see it. So if left mouse button moves in and out, right mouse button goes basically tilts your camera, and then if you use both of them, it moves up and down, so left and right mouse button. So that takes a little bit of getting used to, but that's the perspective environment. Also, you can use W, S, A, and D, and that's might be preferred by some people who basically are controls for first-person shooter. Okay, so we'll look at the other viewports. Similar, hold down the left mouse button, You can move around. You can use the middle mouse button to scroll in and out, and the left and right mouse button both do the same thing. So the 2D viewports have a lot less options. As far as any other controls to move around, there aren't any. So you basically have to use the shortcut. There's unlike some programs that you can do something 20 different ways, this program is a little bit more focused and has less options, so you have to be careful with it. Okay, so what we want to do is we'll create something, and the way to do that is we want to use what's called a brush, and a brush is basically a basic shape. Brushes are terms that are used for, actually it has to do with, they're considered solid pieces of geometry, and you add and subtract from them, which is called a Boolean operation, and this is how you make physical space in your level. So you wouldn't want to make a tree using this, but you would want to make walls and floors, anything that you can't go through, that you're going to run around. And what we're going to do is we're actually going to build a lot of our levels for a while just using brushes. Now right now this brush, you can see there's a grid and there's a different size, and actually we go in the right hand corner, lower right hand corner, you'll see it says 16, so this grid is basically 16 units for each of these. Now there's a lot of modularity, so you usually want to use that. Here's the brushes, and if we right click this or left click, we're going to come up, and right now we can see that we have a space that's 256 units by 256 units by 256 units, so it's a cube. Just to let you know, a character's height is 96 units, and they can jump 64 units in addition to that. So generally 256 is okay. It can get a little claustrophobic, and as far as being able to move around for a character, it's a little small. So what we're going to do is, you can see here that Z is up. So we'll leave 256 as is. Actually, no, we'll increase it a little bit. We're going to do 1024 and 1024 and 512. And we change that, and now you can see the size changes for the brush. And in these viewports, you can't even see it anymore, so you'd have to zoom out a little. And there it is. Now, this is just a placeholder. This isn't an object. It's almost like imagine like a stamp that you're positioning. We can close that out. But what we want to do is we want to use CSG, which is constructive standard geometry. These are the mains one we're going to use. Add is basically going to create a positive solid, whatever shape, and subtract is like a cookie cutter. It'll cut it out. So if we do add, we get a shape that's just made, and if we actually pull the brush away, you can see that the object is still there. So this is how you can, and this is a basic floor for a game. Now what I'm going to do is I'm going to move this back to where it was. And the problem with this is we basically don't want to work with an outside environment. We want to work with doing more like a dungeon and an internal environment in the beginning, so we don't have to deal with suns and atmospheres and that kind of stuff. So we want to take the brush and we want to scale it a little. Now the scaling for some weird reason is set to 5%, which doesn't relate to 2, 4, 16, 32, which is basically the units you want to use. So if you want, you can change this to 2%. You increase your odds of it actually snapping positive. Okay, so the way that you adjust this is, here's your selection tool, and we've been using the move tool. There's a rotate tool, and then here's scale, and this is universal scaling in every direction. So if we grab this and we hit it once, and you can see it's pretty subtle. But if we get that and we look, you'll see that now on every edge there's been a little bit of space that's been added, and it's relative to the side because we're doing uniform scaling. If you'd rather do it separately, there's this one, which is non-uniform scaling, and then you can scale each element on its own rather than trying to do them all at the same time. And sometimes that's a lot of times what you're going to use, but that's what these two are. Okay, so we've repositioned our brush, and what we're going to do with this brush is, rather than hit positive, we're going to hit negative. So we hit subtract, and it looks like nothing has happened. But if we actually move in, holding down the left mouse button, and then holding down the left mouse button and the right mouse button, we actually made a room. So this is kind of the basic idea of how you build stuff. You basically make positive to create the wall, and then you hollow it out is the way that you do this. And so what we'll do is, if we go to play this right now, which we can basically test it, if you hit play at this point, you can do a couple ways. You can play in viewport, or you can right click and you can say play level or play from here. And what will happen is you'll see that we get absolutely nothing. So you hit escape to get out of the play mode. And what we're missing at this point is, right now you'll see that the preview option is unlit. The other views that we see are basically showing the brush wireframe. So if we do unlit, if we go to lit, you'll see there's absolutely nothing here. So we need to add a light. There are no lights by default. So we would right click and choose add actor, add point light, and voila, we have light. And the way that the graphics is, we'll have real-time updates, so you can move that around in the room. The one thing you don't want to do is you don't want to have the light exactly on the edge like this, where it's on because half of it's on and half it's off, so you have a 50-50 chance it'll actually light the room. You would kind of bring it down, and then you can move it around and you can play with different options. So now I have a light, and if I go to hit play this time, get the same thing. Lights need to be rebuilt. So I'll hit escape. So what we've done is we're seeing real-time lighting, but a thing called a light map, which basically writes the lighting data to each of the surfaces, hasn't been created. And the way you do that is you basically do building, which is kind of like a rendering, and it also optimizes the geometry. So there's a button right here for build. And if we hit that and we do build all, which builds everything, that's the easiest way to do it. And what that'll do is that'll build the geometry, and it'll calculate the lighting and also paths, which we'll look at next class. So you're going to wait, and it'll build the map, and it's going to get some data and get some information, and it's going to calculate it. And let's see, and we also have this thing called Swarm that's currently open. This is the Swarm's the render engine, and what Swarm does is, if you have multiple computers hooked up, it allows you distribution, so multiple computers can calculate lighting. So right now my laptop's called red, and that's the only thing we're seeing is just the one space that's rendered, and that's pretty easy. That takes a while to do. So what I recommend is, it's more photorealistic when you do what's called light mask, where the light bounces around. But if you're trying to do something quick and dirty, let's disable that. So we go to View, World Properties, Light Mask, and we just turn off Global Illumination. Global Illumination means that the light bounces around in the space. If you turn that off, it basically just radiates out from the light. What it hits, it illuminates, and that's it. So rather than calculating all these rays bouncing all over the place, you just calculate them hitting once. So disable that, and then you can always come back and turn that back on. And now, if I close this out and I go to build again, build all, it goes much, much quicker. So we're going to have two options here. One is maps not built with production lighting. Unless you have global illumination, proper settings, it's always going to yell at you. The map should have a kill Z set. This is basically a kill zone, and what it does is, if you fall out of the environment for some reason, it basically causes your character to die, so you don't go forever. So we can close this out, and to adjust the kill zone, if we go into View, World Property, there's a zone info, and you can see there's stall and kill Z, and right now it's at negative 262143 units, which is probably in kilometers by the time you calculate it. Each Unreal unit is 2 centimeters. So what we can do is we can actually make this pretty close. Let's do just negative 1024. And let's zoom out in the front view. And there's the red line. That's our kill zone. So you always want to make sure it's further down than where you're playing, but make it close. The other thing it does is it helps with the physics engine, because it only has to calculate this distance as opposed to calculating forever. The smaller the space, the more efficient the physics engine is. Okay, so we can close that again. And now we have these items. And now if I go to build again, okay, we just get the maps not built with production lighting. So go to play this time, and you'll see that my character just fell down in space, and I can walk around and see the environment. And I don't have any physical presence besides just being able to navigate.